All right, IBSL1. We're back with a shorter video to talk about what does the B value do in the equation. So far, we've talked about the A value and the D value. Just a quick reminder that this affects, it's like all transformations, that this affects your vertical stretch, which in terms of a sinusoid means that it affects the amplitude of the curve. This is your horizontal, vertical, come on, Jelly, vertical translations. That's the same with any sort of function, that if you add some number on the end, it moves it up. If you subtract, it moves it down. But in terms of a sinusoid, I say that this affects the center line, I guess is one way to put it. Sometimes I call it home base, but it's that line that cuts right through the middle of your sinusoid. Now, this first one, I've set up a graph that goes from 0 to 2 pi is one full period of a sine curve. Please also notice that I've sketched in a little ghosty sine curve there. So it's like a full mountain, then touches at pi, then valley, back at 2 pi. Top of the mountain is at pi over 2, bottom of the valley is at 3 pi over 2. Now, the question is, what's going to happen to the curve if I put a 2 inside of the function? Well, the answer is that it's the same kind of transformation we've always done. A 2 inside the function affects the horizontal. But when you're inside the function, it's always backwards of what you think it should be. So instead of 2 stretching it, it actually compresses it. So it would compress it by a factor of 2, which means that instead of touching here, the top of the mountain wouldn't be at pi over 2. It would now be at pi over 4. Then it would go up and then come back down at pi over 2. And then go into the valley at whatever that is. And then back up at pi. But it would continue like this. It's sinusoidal. It's cyclic. So it keeps going like back up the mountain, back down to home base, then into the valley, and then back up again. One thing to notice in between 0 and 2 pi now, that you see 1, 2 full sine curves in between 0 and 2 pi. So the period of this curve, the period is going to be pi, because it repeats from 0 to pi. Every pi, it starts cycling again. What if I was going to do y equals sine of 3x? Well, this means that you would get a horizontal compression by a factor of 3. So I'm not going to do exact, I didn't do the right tick marks for this, but let's see. Let me see the full one there. So it'd be like full one from here, and then from about here and here. Okay, I think I'm ready to try this. That it would go like up, down, back up, down, back up, and up, down, back up in between 2 pi. Now, those are not exact, this probably shouldn't hit at pi, but do you guys see how there are 3 full sinusoids? There's 1, 2, 3. So, if this distance from 0 to here is 2 pi and you divide it by 3, that means each of those curves is going to be 2 pi divided by 3, which is 2 pi over 3. So you start to see this pattern of this is the number of how many full sine curves fit in between 0 and 2 pi. So if there was going to be 4 of them, that means you'd see a full one from 0 to pi over 2, and then another full one, and then another full one. Oops, oh no, it started making a curve. Sorry, I'm trying to make these exact. So between 0 and 2 pi, you would see 1, 2, 3, 4 full curves. So the period would be 2 pi over 4, which is pi over 2. Every pi over 2 it repeats. Now, those were all whole, like, large integer values of b. Let's talk about a fractional b value. Remember that if you have x over 2, that's the same thing as saying sine of 1/2 x. Now, the way I think of this is that half a sinusoid is going to happen between 0 and 2 pi. So that means we're not even going to get through a full mountain valley in between 0 and 2 pi. We're just going to get through half of the curve, which would be the mountain. So it's going to start at 0, 0, but then at pi, it's going to go up the mountain, and then at 2 pi, come back. So it goes up, touches, back down, and then, like, let me see, 1, 2, 3, 4. It would touch over here, I think, and then keep going. So I didn't make my graph big enough, but you have to think about, like, where would it finish one full cycle? So if we're going to say what the period is, it's, it would be double, because we only see half the curve between 0 and 2 pi, so the rest of it would be out to 8 pi. So allow me to give you guys the magic formula for figuring out what the period is in relation to the b value. So the period of a curve is equal to 2 pi over b. This is because each time you were like, okay, how many fit into a full 2 pi? The, like, fit into is just another way of saying divide. So you can always remember, like, if it's a sine of 5x or something, that means in between 0 and 2 pi, there's going to be 5 full sine curves. So the period would be 2 pi over 5. Also, that last one where we had, like, a b value of 1/2, you know, if b is equal to 1/2 and we want another period, you just say period is equal to 2 pi over 1/2. But then if you're dividing by a fraction, you keep the top and then multiply by the bottom upside down, so then we get 4 pi. So that works for that last problem, this one, where we kind of reasoned... Oh, sorry. I put 8 pi. That should have been 4 pi. My bad. Four pi. So yeah, it works that we get 4 pi by just plugging in a b value of 1/2 into this guy right here. All right, you guys, it's just a horizontal squish and stretch, same as we've always done, but it affects the period.